Activate Math Questions Week 3. Number 1, on the real number line, what is the midpoint of -5 and 17? So you can't actually draw a number line going from -5 to 17 and count your marks until you reach the midpoint, which would be the value of 6. If you don't want to take the time to do that, since you're finding the midpoint between two numbers on the number line, that's the same thing as finding the average, which means we will add the two numbers together and divide by 2. So -5 plus 17 is 12. 12 divided by 2 is 6. And then before you walk away from the problem, make sure that that's truly the midpoint. So 6 is 11 units away from 17 in that direction, and 6 is also 11 units away from -5 in the opposite direction. So B, the midpoint, is 6. Question number 2, if 3 3/5 equals x plus 2 2/3, then x equals what? So you're solving for x. So to get x by itself, to isolate x, you're going to subtract 2 2/3 to the other side of the equation. So essentially, you've got 3 3/5 minus 2 2/3. Now, if you are good at entering mixed numbers into your calculator, you could simply use your calculator at this point, but sometimes that gives folks trouble. So I'm going to change these into improper fractions by saying 5 times 3 is 15 plus 3 is 18. So as an improper fraction, 3 3/5 becomes 18/5. Now I'm going to subtract from that. Okay, 3 times 2 is 6 plus 2 is 8. So that's 8/3. So again, subtracting 2 2/3 is the equivalent of subtracting 8/3 as an improper fraction. So again, from that point, entering those fractions into your calculator is a little easier. But if you want to continue without a calculator, without the use of a calculator, you're going to have to get a common denominator to subtract those fractions. Since my denominators are 5 and 3, my LCD, or my least common denominator, will be 15. So I'm going to write two new equivalent fractions with the denominator of 15. And to do that, with the first one, I ask myself, how many times will 5 go into 15? And that's 3 times. So since 5 times 3 is 15, 8 multiplied by that same 3 will give me a new numerator of 54. So I've created an equivalent fraction with a denominator of 15. And then I'll do the same thing with the second fraction. I ask myself, how many times will 3 go into 15? 3 will go into 15 5 times, so I'm going to multiply this 8 by that same 5 in order to create an equivalent fraction. And when I do, the -8/3 equivalent is -40/15. So then I'm ready to actually subtract my fractions. My denominator will remain a 15, and then I'll say, okay, 54 minus 40 is 14. So the x value that will satisfy that equation is the value of 14/15, answer choice G, and you could always check that by plugging that number back into the equation for x. Number 3 gives us a system of linear equations. And we're asked which of the following describes the graph of this system of linear equations in the standard xy coordinate plane. And if you are familiar with standard form, that might help you reach your decision, but most folks would like to see those equations in slope-intercept form, because if you know specifically about the slope and y-intercept, that can help you with parallel lines versus a single line versus two intersecting lines. So I need to get y by itself in order to get my equations into slope-intercept form. And to do that, I will divide both sides of the equation by 3. So that first equation in slope-intercept form becomes y equals negative 2/3 x plus 8/3. When I do the same thing to the second equation, y equals 2/3 x plus 8/3. Now, if you still were not sure and you had a graphing calculator, you could graph both of those equations and see what happened on the coordinate plane. But we do know that parallel lines have the same slope. This slope is negative, this slope is positive, so they are tilted in opposite directions. So I do not have two parallel lines. To be a single line or to be the same line, the equations must match up exactly. Well, since the slopes are different, you're not going to have the exact same line. So we do have two different lines. And I'm left with answer choice A, two distinct intersecting lines. And in fact, if you do graph those using a graphing calculator, you will see those two lines intersect at one point. Question 4 asks which real number satisfies the equation 2 to the x power times 4 equals 8 cubed. And there are several ways to approach this problem, but I would probably begin by raising 8 to the third power, and that is 512. I'm trying to solve for x. So I'm trying to isolate it, which means I need to get rid of this 4. I need to move the 4 to the other side of the equation, and I can do that by division. The 4 is multiplying the 2 to the x power, so I'm going to divide both sides of my equation by 4. So that'll leave me with 2 to the x power equals 128. And honestly, from there, if you wanted to, you could guess and test using your answers, and you could have done that earlier in the problem as well. But essentially, you're looking for 2 to the what power, or what power can you raise 2 to, so that you wind up with 128. You could let your calculator help you. You could use a table of values to help you, but you'll find that 2 to the 7th power is 128. For those of you that are familiar with logarithms, you could have rewritten this equation as log base 2 of 128 equals x, but that's really unnecessary if you have a multiple choice question. So again, the answer is K, a value of 7. And number 5 shows us a graph in the standard XY coordinate plane, and it's to be rotated in the plane 180 degrees about the origin. So this is the origin, and we're going to rotate 180 degrees. Since we're rotating 180 degrees, it does not matter if we rotate clockwise or counterclockwise, but we're trying to determine which of the graphs match that rotation. So essentially, you're taking this figure and you're rotating it 180 degrees. As you can see from your answer choices, you can start eliminating, because essentially this graph that's on the right-hand side of the coordinate plane, when you rotate it 180 degrees, will be onto the left-hand side of the coordinate plane. So you can immediately eliminate some answer choices, such as answer choice A and answer choice E. If you completely rotate 180 degrees, some of these points that are above the x-axis here will wind up being below the x-axis as you rotate around. So again, you can eliminate now answer choice B. And if you see you've got two peaks or two little maxes on your graph currently, if you rotate it around 180 degrees, those maxes will turn upside down and become mins, so D is my final answer.